Lesson 57, properties of the definite integral. So, as we were just discussing, yes, there are just basically a whole bunch of properties listed on the front page there. There's not really anything to do till we get down to example 1, but I'm going to try and not take a whole lot of time, but kind of just run through what each of these properties is saying. And then a lot of these properties we'll use in our examples, which will help you to understand them. Okay, so that first integral or property there says the integral from a to b of f of x plus g of x. That's just saying if you have pieces being added within an integral, they can be broken into separate integrals. And so the integral from a to b of f of x plus the integral from a to b of g of x. So it's just saying that if there's pieces being added, subtracted, you can break them apart into separate integrals or put them into one integral. The second row here says the integral from a to b of k times f of x is equal to k times the integral from a to b f of x dx. And that's saying if you have a constant of some sort, not a variable has to stay within the integral, but if you just have a constant, it can be pulled out front, and that way, in certain situations, it makes life a little easier because you're not worrying about it. The third example there is helpful at times. The integral from a to b of f of x is equivalent to the opposite of the integral from b to a. So if, for certain reasons, you need to flip your boundaries, when you flip the boundaries, it just means you put a negative in front of the problem. And that's what that's saying here. We'll definitely use that one. So the integral from a to b is equal to the negative integral from b to a. This one, the integral from a to b of f of x plus the integral from b to c of f of x. So notice my insides are the same. They're both f of x. Notice it's a to b and b to c. Notice those b's match, yes? Because those b's match, the top integral of one, or the top boundary of one and the bottom boundary of the other, this can be rewritten as one integral from a to c. And again, that's only because these b's are matching. Okay? The integral from a to a is always 0, meaning if you're going from one number to the same number, the boundary, that integral is always equal to 0. Let's see, next one. I'm off the screen there, aren't I? Not that it matters too much about my pointing, but if my function is greater than or equal to 0 on an interval, so if my function is positive, then my integral is positive. If my function equals 0, on an interval, then my integral equals 0. If my function is negative, then my integral is negative. Okay, just some basic facts there. Where am I at here? G of x is less than f of x. So if one function is less than the other function in terms of values on an interval from a to b, then the integrals are also less. So if g is less than f, then the integral of g is less than the integral of f. Same idea here. If the functions are equal, f and g are equal, then their integrals are equal. Okay? Again, just some basics summarizing. There's only so much I can actually talk about on those. Let's go into some examples.
How come on the very last one it has a C?
I'm going to go with typo. Let's go with, that should not be a Z, that should be an A. Didn't even catch it. Yeah, there's no Z's there. They're all A to B's. Okay, example 1. And these are good multiple choice type questions on AP. Let the integral of f of x from -1 to 1 equals 7. And the integral of f of x again, this time from 1 to 4, equal 2. Evaluate. So solve. Give me an answer. I want to know, what does the integral from negative 1 to 4 of f of x equal?
Yeah.
You add them together. Do you see it? They're asking me to find the integral from negative 1 to 4 of f of x dx. That's what I'm being asked to find, right? Well, notice negative 1 to 4. What do they have it broken up as? Negative 1 to 1 and 1 to 4. So the idea that negative 1 to 1 plus 1 to 4. They're all f of x dx. So as long as that's consistent, we can use that idea. The key is to watch the boundaries. Negative 1 to 1, 1 to 4. Notice these ones are matching. So we could be put together into one integral going from negative 1 to 4. The nice part is they just so happen to tell us the values of these two integrals, didn't they? The value of the integral from negative 1 to 1 was 7. The value of the integral from 1 to 4 is 2. And 7 plus 2 is 72 in Nathan's world. I'm not going to write 72 down. I'm going to go for 9. Questions there? Okay. If you're ready, let's flip to the back. Try example 2. And example 2 and example 3 are similar in that we're just trying to manipulate so we can get what they want us to get. So f and g are functions such that the integral of f from 1 to 3 is equal to 4. The integral of g from 1 to 3 is equal to negative 1. Evaluate the integral from 1 to 3 of 3 times f of x minus 1/3 times g of x dx. The idea here, can you guys see where we're going with this maybe? Okay. They defined the integral from 1 to 3 of f and from 1 to 3 of g. We need to get this broken down so that that's what we have. So first of all, subtraction within an integral can be broken up into two integrals being subtracted. Or addition within an integral could be broken up into two integrals being subtracted or added. So I'm going to first of all break this up. The first integral being the integral from 1 to 3 of 3 times f of x, and then it will be dx, minus the integral from 1 to 3 of 1/3 g of x dx. So that's kind of my first step I took. And again, you may be seeing it more and not needing me to do all these baby steps. I don't think you'll need me to do the steps as much after you see it the first time. Now, we have constants. What do we know about those constants officially? Yeah, those constants officially can go and move out front of the integral, yes? And so if I move that constant of 3 out, it's 3 times the integral from 1 to 3 of f of x dx minus 1/3 times the integral from 1 to 3 of g of x dx. Are you seeing the pieces here? 3 is 3, yes? What do we know about the integral from 1 to 3 of f of x dx? It was defined to be 4. So this part becomes 3 times 4. Minus 1/3 is 1/3. What do we know about the integral from 1 to 3 of g of x dx? It was defined to be -1.
37.
I'll take it. He says 37/3. Has anyone else done the math yet? I'm going with 3 times 4 is 12. It's minus 1/3 times -1. Well, 1/3 times 1 is 1/3. Minus times negative is really going to make it plus 1/3. So my brain says 12 plus 1/3, which is 12 and 1/3, which does become 3 times 12 plus 1, 37/3. 12.3 repeating, 12 and 1/3. We just don't do a lot with mixed numbers at this level of math, but that was the easiest way for my brain to convert. Did we make it there one way or another? Okay, so again, it's not that a lot of these properties, it's not that there's difficult, it's just being able to recognize. All right, maybe I'm speaking for myself. I guess I look at it this way. We do a lot more difficult things in calc than this. We've done a lot more difficult things than this. I mean, you know. Okay. There you go. Perfect example, the infinite rectangles. Which has a whole page just to write the steps out. So, okay, example 3. Okay, suppose the integral from -2 to 1 of f is equal to 3. The integral from 3 to 1 of f is equal to 7. And we need the integral from -2 to 3 of f.
We can make the second one negative integral, so we can flip this, so we can put them together.
Okay. So we're needing -2 to 3. Here's -2. Here's 3 on the bottom. The problem is that my ones are both on top, right? So if we can get this to be -2 to 1 and then 1 to 3, well, how can I flip those? If I make this negative. And so that's equivalent. The integral from 3 to 1 of f is equivalent to the negative of the integral of 1 to 3 of f. So, let's look at the pieces here. The first one they gave us is the integral from -2 to 1 of f of x dx, right? Plus, and now we're doing the negative integral of 1 to 3 of f of x dx. Is that going to work? Yeah, that's going to be the integral from -2 to 3 of f of x dx. So it's just a matter of getting the values. What was the value of the integral from -2 to 1? 3. Plus negative. What was the value here? 7. We just had to make it negative because we put a negative on the integral. 3 plus -7 is -4. Okay. Ready for our last one? We're going to go a little deeper with this last one, though. Assume f is a positive valued continuous function over the interval from 5 to 8. So it's continuous, so we can just draw it. No gaps, no stops, no breaks. It's positive, which means it's above the x-axis. And it's in the interval 5 to 8. Assume also that the absolute maximum of f over that interval is 12. So the highest point that function goes is 12 in the interval. And its absolute minimum over the interval is 3. Using the properties of this lesson, state the maximum and minimum values possible. No, not quite. There's a slight catch we have to look at. So, okay, I'm going to sketch a graph. I need a visual to point to here. Okay. This is a continuous function over the interval from 5 to 8. So we're going to be specifically looking between 5 and 8, yes? We know it's going to have a maximum value of 12 and minimum value of 3. So that means the highest my function can go is here at 12, right? And the lowest my function can go is here at 3. I don't really know what it does before and after here, but I know it's continuous. So I made that a little more vertical than I meant to. Oh well. That's my continuous function. Am I continuous between 5 and 8? Yes. Do I have a absolute max of 12? Absolute minimum of 3? If it was a large interval, I might draw some other ups and downs in there. But there might be ups and downs. There might not be. Okay, so there could be other maxes and mins, but these were the absolute maxes and mins. And if you, I guess I didn't point out here, it says state the maximum and min values possible for, and it shows that integral there, yes? I kind of overlooked and forgot to mention that. Integral from 5 to 8 of f of x dx. What do we mean integral? How does that transform into geometry type stuff? Or maybe I shouldn't, I don't know if I want to say geometry type stuff. The idea that, okay, when we talk about derivative, what's the algebraic connection? Okay, well, derivative is slope. Integral is area under the curve. And so the idea here is that if we're trying to find the integral from 5 to 8, we're trying to find the area under the curve. Okay. Now, specifically, they didn't ask us for the area under the curve. They asked us for the maximum values and minimum values. So let's talk up here maximum value. The highest this curve ever goes is 12, yes? Over how big of an interval? 3. So if this curve was drawn differently, and filled up this whole area, we're talking the shape of a rectangle. And what's the area of that rectangle? What? 12 times 3. A maximum height of 12 times a width of 3, and 12 times 3 is 36. So that would be the absolute maximum. Now, not likely to actually, be at the maximum, but right there, that's the highest point, yes? What about if we're at the lowest point? It's a height of 3 times a width of 3, and 3 times 3 is 9. So 9 is my minimum possible value. I forgot to write it up here. 36 was my maximum possible value. So the idea going along with, again, area under a curve is what an integral is defined as. If I write this, let's see, if I write this a little fancy, maximum and minimum values, what we're saying is the integral from 5 to 8 of f of x dx has to be less than 36 and greater than 9. So if you want to write a fancy answer here, and more importantly than anything, it's just me trying to explain notation to you. But they ask for maximum and minimum possible values. So it's less than or equal to 36, greater than or equal to 9. Okay, did we get what we need there? Questions I need to answer?